Um, as the title says, I'm the convener of the SC32 WG3, and I'll talk a little bit about what that means in a bit. But in the spring, in April, we actually published a new database language standard for GQL. So the question is, what does that actually mean, and what happens now? Bit about me. Basically I'm a database geek. I've been doing databases and production applications for something close to 40 years now. And along the way, I ended up as the convener of the International Committee for Database Languages. The convener is the person who has the responsibility, not necessarily the person who is in control. Sometimes I use the term cat herder to describe what I do in WG3. And I've also, for several years now, been working with Neo4j, specifically on GQL. So I want to give a quick context of what is a standard, a little bit about the GQL standard and who created it, and then spend a little more time on what it means to actually conform, for an implementation to conform to the GQL standard. I've got a slide where I list the products that I know about that have announced GQL implementations, and then talk a little bit about what happens after GQL version 1. So standards are agreements between participants on how to do something. And so basically a group of experts get together and come to an agreement. And the goal of a standard is to benefit both businesses and consumers. For businesses, to make it easier and cheaper to cooperate and to compete, and for consumers to increase choices and decrease costs. There's all sorts of organizations that create standards. This is a wildly incomplete list. The committee I work with is underneath the combination of ISO and IEC, and I'll talk a little bit more about that. But a couple of examples of other standards that have made a difference in the world. There is a standard for freight containers, and it's sort of a visual thing that you can think of. The containers that load on a container ship are based on an ISO standard. And what they do is they reduce the cost of shipping goods worldwide because they have standard sizes, and so you just pack a container and ship it, and it can be moved by ships and trucks and trains. Another standard that my guess is many of you are taking advantage of right now is a standard for wireless networks, which is from IEEE. One of the points that's interesting about the wireless network standards is that there have been variations over the years as new versions of the standard, as new technology came about and new versions of the standard were created to improve the wireless networks. In database languages, there are two standards. One is for SQL, which many of you have probably heard of, and then the new standard for GQL, for property graph database languages. I could spend a long time talking about SQL, but I'm not going to. The important thing to remember is that there have been versions, expansions, and additions to the SQL standard. The most recent version was published in June of last year, 2023, and it's made up of 11 parts, including part 16, property graph queries in SQL, the SQL PGQ, and there'll be a talk later about that. The GQL standard, we decided that it made sense to have a separate database language standard for property graph databases. The project was approved by the international community in September of 2019. We did a little bit of work, and the standard was officially published on April 12th of 2024, so several months ago. It's a full database language standard, full database language. So there's data manipulation language to create, read, update, delete data. There's data definition, and the GQL standard supports or defines two options. One is a flexible schema, where basically you insert data and the data you insert controls what the schema looks like. And the other is a fixed schema, where you create a graph type and then you create a graph from that graph type. And a lot more can be said about that. There'll be more discussion of that in later talks. The reading the data, querying the data is done with the graph pattern matching queries. And that's worthy of at least an hour talk, so I'm not going to describe it. But the important things to remember about the GQL standard is that it's built on a foundation of capabilities in SQL, capabilities in other property graph languages, and other standards such as Unicode and IEEE floating points and the ISO dates and times. So who actually created the standard? The committee that I run, WG3, is a working group of SC32, which has a number of groups in data management interchange, and that is a subcommittee of what's called Joint Technical Committee 1, which is underneath both ISO and IEC, two separate standards organizations. Most of the computer language technical standards occur in JTC1 committees. The committee is made up of individual experts that are delegated by the various national body standards groups. So we've had participation from China, Denmark, Finland, Germany, Japan, Korea, Netherlands, Sweden, United Kingdom, and the USA. So it really is an international standards organization. So how is a standard actually developed? The way WG3 works is people write papers, and the papers get discussed. Sometimes they get modified, sometimes they get rejected. For GQL version 1, there are somewhere over 430 papers that contributed to the shape of GQL version 1. So that's a fair number of papers. They range in size from 4 or 5 pages. I think the longest one was about 170 pages. We had lots of meetings. My count is that it took 11 face-to-face meetings and 27 web conferences. And if you think about web conferences, if you look at the countries that had participants in the standards committee, organizing a web conference when you have people from around the world means that somebody is meeting at an awkward time. But people persisted and we got it done. And it took about 5 years. Building a standard is not actually very quick. It does take a lot of effort and a lot of time. And while it seems to proceed at a snail's pace sometimes, it actually seems to work, process seems to work fairly well. So who actually uses the GQL standard? It's primarily geared at property graph database vendors who are building products, but also open source projects such as the LWC work and academic researchers. The end users will use property graph database products that implement the GQL standard. They won't necessarily have to read the standard itself. So we have a standard. Now we need some implementations. To that end, we have some aids to implementing, and I'll talk about the GQL artifacts of the LWC working group. One of the important things is a conformance statement, because that's a way that a GQL implementation can tell their users what parts of the standard they actually implement. And eventually, GQL version 2. The artifacts are generated as part of the process for generating the actual standards document. And it includes things like BNF, list of exception conditions, optional features, etc. Those can be downloaded from an ISO website at no additional charge, no charge at all. So if you want to see what the syntax is, you can go download the BNF. The LWC GQL implementation working group has been working on a number of things, and Michael Burbidge and several other people will talk about this in the next talk. What does it actually mean to conform to the standard? Well, the standard's a bit complicated, and we've got a set of mandatory features, some optional features that are mostly specified in conformance rules. A few things are specified elsewhere. And there's a requirement to document a number of implementation defined elements. One of the challenges of the mandatory features is that it's everything that isn't optional, but there's actually no nomenclature for the mandatory features. There are a couple places where things require support for either option A or option B. And that's something you have to dig in a little bit to understand. But basically, the requirement is that GQL implementations need to document their conformance in a conformance statement. The conformance statements are designed so that users can read them and compare different implementations. I'm not going to go through this slide, but something you can read later. But this is extracted from the minimum conformance section in the GQL subclass 24.2. What's a conformance statement look like? Well, SQL database vendors have been writing them for decades now. And so I think GQL conformance statement can be modeled on SQL statements. A couple of examples are listed here, Postgres and Oracle, but you can find other conformance statements. Several companies have announced some level of conformance. Neo4j has documented their conformance in a conformance statement. Google Spanner recently announced a version that has some elements of SQL PGQ and some elements of GQL. They have not yet published a conformance statement. Vsoft has announced that Nebula Graph will support GQL. I haven't had time to look at this, but a beta test release was released in June, and there's, I believe, an update to that was released recently. And at the June SIGMOD conference, Altipa, Ricky Sun of Altipa said that Altipa would support GQL in later this year. So there are implementations. The thing to look for on an implementation is both the documentation of what they actually do and how they work, and what they say they do relative to conformance. So what happens after GQL? we got a lot of ideas. We're doing some bug fixes now. The extended schema working group is working on schema information graph, various other things under discussion. And I don't know yet what the timing is going to be, because it's going to take vendors a while to implement GQL. It's going to take users a while to absorb it, and it's going to take us standards participants a while to write the new papers for V2. But it is in the works. It's beginning to simmer. So we've got a new standard. It's a full property graph database language. I'm actually really excited about it because it's a brand new database language that it's the first time since the SQL standard was released in 1987 that there's been a new database language standard. And we're beginning to see implementations of GQL and see people talking about it. Any questions?
Keith, it's Alistair. I have a question. Did you mention LDBC's presence in WG3 through our liaison with WG3?
I did not. And yeah, on my list of participants, I should update it to add that. But yeah, LDBC has participated and has affected what GQL version 1 looked like.
Cool. And I guess the other comment I'd have is, I think one of the things we've detected in the discussions since the standard came out is that the conformance statement, the minimal conformance statement, is very minimal. Like, you could have a language that doesn't even implement database updates, database mutations. So there's a kind of a gap in terms of what does a genuine minimum profile of GQL look like. I think that'll be an interesting thing to try and work out through the various efforts that are going on around implementation.
Yeah, the conformance was deliberately designed so that an implementation that only had a read-only GQL database, so you could query it, but you couldn't insert update data, could claim conformance. And so that's the sort of minimal subset that is specified. The conformance is a bit convoluted, I think it's fair to say.
Okay.
My only other comment is that what I claim is that WG3 goes to interesting places and then sits in conference rooms and stares at our computers. But this was from Sonia China in June.